All right. So we got 2 teams, 5 each. These 5, those 5. Here is your device over here, your device over here. And by the way, if you'll notice here, it says attach a 500-gram mass to the cord of the pendulum. Now this will be our pendulum here. There's 500 grams. That is 500 grams. Yeah. Okay. First thing it says to do, record that mass in kilograms. You got it. 0.5 kilograms. Now, each team has 2 meter sticks, and what I want, well, this team's supposed to use the meter stick team. Okay. Okay. Now, oh, Terry's here. Good. You can go in either team you want. Okay. So you can either be in this team or this team. 6 in this, 5 in that. Okay. Now, you've already done the first one. Oh, and by the way, to answer 10 or more questions, we're not doing that, so don't worry about it. I know y'all are already writing on those, but don't. Okay. So one of you with a meter stick, or a couple of you, get here and measure how far the minimum distance of the mass is from the floor. And I would measure to the bottom of the mass to the floor. So that's a straighter line. So, and put the 0 on the floor and measure how far, and get to the nearest tenth of a centimeter, but you want to record this as meters. Okay, but convert it to meters. That would be in centimeters. What would that be in meters?
40.6 meters. Right. Meters.
Again? Not okay, whatever. That sounds reasonable. What did yours come up be? 0.41 meters. That sounds reasonable. Okay? Now, I'm going. Oh, you got that. Okay. I'm going to demonstrate what each team would do literally. You don't have to do this. But what I'm going to do is now put this so the mass is on top of the meter stick. Okay. I'll let everybody got the first 2 questions done. Okay. Now with the mass on top of the meter stick, what is the change in vertical displacement from the 0 reference level?
You want to put that height, right?
Okay. This is how far?
We're talking about a meter.
You have 1 meter. And what was it down there?
Subtract that from that.
Yes, exactly. Okay. Makes sense?
Meter would be what? 0.78.
I'll let y'all figure that out. Okay?
We gotta subtract that number.
Okay. Now the question is, what's the difference from where it was to where it is? Huh? Okay, yeah, you got it. Okay. All right. Everybody got number 3 done. Okay. Now, just because I have more room this way, if you let me bum yours a minute. Okay. Oh, you could have stayed there, couldn't you? No. Okay. Now, what I want you to do now, and you could think of what you would be doing over here. With this on top, what is the gravitational potential energy of this mass?
Potentially, you have 4 potential energy.
Okay, all of it is what you say? Okay, you multiply something with 9.8, what does that something do?
Gravitation.
Mass
Mass
times 9.8 times, yeah, your change of height. What you had in number 3. So your mass was number 1,
The unit
kilograms. Okay, and your G, you know what units those are, and then you know what units they are, and then your delta H in meters. That's what you put in number 3. Okay, so you got 2 teams, so they're going to be different numbers. All in one team to be the same one the other. So this is the first part of number 4. What is your GPE, gravitational potential energy, at the top of the meter station? Trevor, I thought you were absent today. Oh, I see.
What was it, Slim? You already got it?
And Mason, either me or your shirt has your name misspelled.
No, they did.
They did, okay.
They charge me every week for them to put my name misspelled on their shirt.
Yeah.
Velocity,
Did you get an answer?
velocity at the top would be zero. Initial.
Okay.
When it says
Okay,
when it
that
says
sounds
velocity,
good.
when it says velocity at the top, it means the
Okay,
initial
yeah,
power.
okay, yeah. They've already gone to number 4.2.
What decimal? What place? Decimal place?
2 digits is fine. Because 9.8 is only 2 digits. Yeah, it would be in joules. Kilogram from your mass, meters per second squared from your acceleration times another meter, kilogram meters squared per second squared, that's a joule. Okay. Now, I heard some discussion for 4B. What is velocity at the top of the meter scale?
Zero.
0. Very good. At the top of the meter stick. What would that be? Okay, so what are your
Kinetic
kinetic?
at the top?
Yeah.
It's gonna be 0.
0 also, because kinetic is 1/2 mv squared. If v is 0, kinetic is 0. What's your mechanical energy at the top?
2.89.
Huh?
2.89.
Okay, tell me what mechanical is again.
Kinetic time potential.
Not time.
Plus.
Plus. Whatever you got. You all had a different number. So. Joules. Now, energy is in joules. If you want to put a whole unit, that'd be kilogram meter squared per second squared, but it's like okay. So now I may hit a page. I don't want to. Okay. When I release this, and it would work over there too, I want you to get the table, so that's why I'm using this side. If I release it, what we're asking is, what is the mechanical energy at the bottom? It certainly would, because mechanical energy is conserved, does not change. Yours will be a different number, but you got it. So that's 5A. Got it? Okay, 5B is what is the GPE at the bottom, gravitational potential energy at the bottom.
0.
Why? You're at your 0 reference level. Exactly. Your height is 0 down there. Right? Okay? So what's your kinetic energy at the bottom? Same thing that you had for mechanical. All of your mechanical is now kinetic.
What about velocity? We're going to do it actually.
Oh, we got to do some math. You should say that with a Smile on your face. We got to do some math. All right.
I didn't
Okay.
have to do any math.
Okay.
You said the.
I like multiple choice.
Yes. Exactly. Because zero gravitational. All right. Now, do you need to go out so I can write on the board? Because we don't have a board in. Well, they do, but it's over there. I hate to move it, but
It was left over.
or do you want me to say something about it? Okay. Let's think what we know and maybe don't know now.
Two formulas
Say again?
for each other, like the half mv squared equals
Yeah, that's exactly what we'd be
mv
doing.
something like that.
Yeah, because what Mason's saying there, whether he realizes it or not, you know kinetic energy at the bottom. And joules, which are also kilogram meter squared per second squared, is equal to 1/2 mv squared. So you can write down your KE in kilogram meter squared per second squared. Okay, I say turn on the back and do this if you want. Huh?
The meters cancel out.
The kilograms cancel out. But yeah,
The grams.
okay. You're getting close. But if you want to, if you don't remember what the formula is, whatever your kinetic energy is, and for different groups of different things, we'll put it as kilogram meter squared per second squared. It's equal to 1/2 m. Yeah. The first thing you're going to do is multiply 2 by both sides. 1/2 mv squared. You know the mass, right? You know the mass, right? What? Ah, good. Okay. So the first thing you do is multiply both sides by 2 to get rid of that, the 1/2, and then divide both sides by 0.5. Okay? And that will give you v squared is equal to some number. Right? And then what do you do?
Square root of that number.
Take a square root of it. You got it.
So you do
So I didn't need it to calculate. You need to be outside for me to write, or you are getting it?
you can calculate it out. Do 2.89 divided by 0.2.
What's that?
You got, is that what you're doing?
Which formula? Kinetic energy? Huh? Oh. Yeah. Okay. Okay. Why don't we go to the board? So I'll write it on the board. We'll come right back in here, folks.
Why are you getting rid of that? Yeah. Yeah, you get big on something. When I get the 5 I divide there. I get a number that equals b squared.
Do we know everything else? Yeah. Kinetic energy. Now, I don't know what your numbers are. Those were the everybody got that part? Okay. As soon as you all got that, we'll come back in and do 6 on down. Everybody in?
One more.
One more. These are oscilloscopes.
That looks old.
It is old. But I'm old.
They still use
Alright. Okay. Picking up at number 6 now. Everybody got 1 through 5 with the 4 parts of 4 and 5, right? Okay. I'll need 2 people holding sticks. One over here and one over there. Yeah. Yeah. And move on back some.
And you get the floppy stick if you want.
Okay. So it looks like you're going to be the releaser and you're going to be the measurer. Okay?
Make sure it ain't too close.
Huh?
Oh, yeah.
So here, what it is.
Okay. Okay. Now, y'all are getting it right. Now, this first is just going to be a trial run. Keep your string tight. So move out some if you need to. Okay. Okay. Hold it at the top. Oh, I see. Y'all are just measuring. Okay. Okay, yeah, it's different lengths upside down like that. All right.
Make it easy.
Okay. All right. He's holding it a meter off the top. Now, there's nothing to write here. We're just going to observe. When you're okay with it, you can release it and see about how high it goes here. What would you say? Right about a meter. He was a little below a meter when he started. Okay, about a meter. Okay. So what I'm going to do now is peg this about a third of the way down the string, and you tell me, you may have to come in a little, but you can judge it from there about how high it goes now. It's too close, I think. Yeah. Okay. How high did it go? About a meter. Okay, you can write that down for number 6. You'll remember that.
I got groups.
Okay. Groupies, okay. Okay. Everybody got it? Shouldn't have been that hard. Okay. Now I'm going to peg it about halfway down. And you see about how high it goes.
Oh,
What was it?
he moved.
About a meter. Okay, about a meter. Whoa!
He had to move.
Okay, you want to do it again? Half? Okay. Right about a meter. Okay. That's number 7. Okay. This time I'm going to peg it about 2/3 down. And there will be 2 answers you have to put for here, but let's do it first and see what you get. About 2/3 down. What happened?
You moved your hand, man.
It went
It wrapped around the
Jerked it
peg.
and twisted. I see.
Okay, so
I
what
synced it.
happens?
It
It wrapped around the
It
peg.
went up to a meter, but it.
Okay. Okay, you want to try it again? Oh,
Yeah.
doubting my veracity here. Okay. Is this about 2/3 down?
Yeah.
He's cheating.
Okay.
It almost seemed like you having it going on.
So he twisted his finger, man. He's cheating. I synced it.
Well, I mean, it hits me. I can't hold
Oh,
perfectly
yeah, yeah.
still.
Sound like
Well,
he
let's try
want
it
his
again.
finger enough.
I'll try to be perfectly still.
Oh, he's
Is that
cheating.
about right?
Put your
If you can hold it right here, you use the stick.
Huh?
I can hold this right here, you hold the stick.
It'll move too. That's right.
He's cheating. He's bracing for it.
No, he did.
Okay, it wrapped around the peg. That's the first part.
That's weird. Why?
Okay.
Because of the energy? That was
There's the question. Why? The first part wrapped around the peg. Okay. The second question, though, that you need to also answer is why.
The kinetic and potential energy swap places.
Okay. You're getting really close there. Why did it go back to a meter the other times?
Because the length of the string is different.
Okay, now that's you're getting there. What difference did that make, though?
Wrapped around the stage.
Because when it could go back to a meter, it would.
There's a point that it.
But when I got too far down here, there wasn't enough string for it to make it back to a meter. And if it couldn't get back to a meter, it couldn't lose all of its kinetic energy to potential. So it still had kinetic energy, which meant it kept moving. Does that make sense?
Mhm.
It still had kinetic energy, so it had to keep moving. And that's why I got it on the test. So be sure you answer both questions. Number one, what happened? Number two, why? Okay? Okay. Now, yeah, we won't need these anymore. Okay? Thanks for your help. One more with your stick.
Oh,
All right. Okay, number 9, someone's moved on to it. What conservation principle does this experiment demonstrate? Mechanical energy, perfect. Because that was conserved. Potential change constantly, kinetic change constantly, but mechanical energy is always the same.
Mm-hmm.
W right where?
Hey, say it again.
Oh, W.
What you just said about it.
I didn't say I wasn't
Dang,
doing it.
dang,
you good, Mason.
That's good. I did the same damn
Kinetic
thing.
energy was always changing, but the sum of them was always the same.
See, I just done that to try to pull James.
There you go.
I wrote it first.
I need.
Which don't make it sound no better.
Okay.
Oh, I forgot my water.
I just need 20. Okay. All right. Now, what you're going to do now is on number 3, number 2, half of you had this in your number 2. The other half, let's do it, had this in number 2. So you fill those in with blanks. So outside, like in the margin here, you put down the other number, the one you didn't have. Right? And then do all your calculations based on that other number. Okay? Number 4 and 5, right either above or below the point. And 2, 3, 2 and 3, right out the mark. Okay? Makes sense? You do the same thing for the other two. By yourself. Okay, I forgot to bring my computer out. The last part of the lab was to the team 1 use team 2 number for number 2, and team 2 use team 1 number for number 2, and then redo your calculations. Okay. Now, if there are questions, I'll answer the questions, but otherwise, I'm going to shut down the recording. Any of you have any more questions? Do you understand what I'm asking for the second part? Okay. All right.